Here we go. This is lesson on Algebra 2, lesson 50, solving and graphing absolute value inequalities. So last week we talked about solving and graphing just regular equations, and we talked about graphing absolute value inequalities that had two variables. Today we're just looking at one variable. Here are the steps. And the steps are similar to last Friday, so except that we have greater than, less than signs. Okay, so here we go. Watch me do number 1 and 2, and then we'll do numbers 3 and 4 and 5 and 6 together. Here we go. So number 1 and 2. So number 1, first thing I'm looking for is I'm asking myself, I'm going to solve. So we have a p here. We want to figure out what is p equal to make this equation true. Okay, so we want to know what the absolute value of p over 6, which is less than 2, what p will be equal to. So the first thing I'm going to do is isolate the absolute value sign. The absolute value sign is already isolated, so watch carefully. Just watch right now. We've got p over 6. Take everything that's inside the absolute value sign and make it equal to, or keep the same sign, less than 2, and then do another one. And watch carefully what I do now. Here's the special step. Watch, just watch. P over 6, change the inequality to greater than, and then change 2 to negative 2. Okay? You all catch that? Okay, then we multiply by 6 on both sides. So we got P is less than 12, and P is greater than negative 12. Okay? And I could write this. I take the smaller number, negative 12, put P in the middle, 12 here. And then we said that P is less than 12, and it's greater than negative 12. So this is the answer. Now we're going to graph it. So we go to the first answer. We got P is less than 12. Go to 12, put a circle down. Do we fill it? No, we don't fill it. And it's going to go to the left. So I'm going to make a mental note that it's going to the left because it's less than. And then I have negative 12. P is less than negative 12, and this one's, greater than negative 12. It's going to the right. So since one of them is going left and one of them is going right, we can graph the amount that's in the middle, and that's it. So we fill one that's in the middle. And the reason why we do that is we're saying that any answer that is in between negative 12 and 12 would make this equation true, or inequality true. Okay? That's all we're saying. So I could pick any number here. I could pick 0. If I put 0 here, 0 divided by 6 is 0. Absolute value of 0 is 0, so 0 is less than 2. That's correct. Or I could even pick 11. Okay, 11 over 6 is 11 over 6. 11 over 6 is almost 2, which is less than 2 over 2. Okay? So we're making the statement true. Number 2. Number 2, we know the absolute value sign is not isolated. We have this 2 here, so we're going to, first thing, we're going to divide both sides by 2, because it's saying 2 times the absolute value, so we're going to do the opposite. So it's going to be 10b minus 7 in its own absolute value sign, which is going to be less than or equal to 37. Now the absolute value sign is isolated, so we're going to take it, and we're going to write 10b minus 7 is going to be less than or equal to 37. And then we have 10b minus 7 is, switch the sign, greater than or equal to negative 37. Okay? So now we solve, add 7 to both sides. Sad map, right? We're doing the opposite of orders of operations to solve for b. So you got 10b is less than or equal to 44. Divide both sides by 10 on this first equation, and we get b is less than or equal to 22/5. Okay, that's for number the first one. Now we're going to do the next one. Add 7 to both sides. So you got 10b is greater than or equal to negative 30. Divide both sides by 10. So we got b is greater than or equal to, this is 10, greater than or equal to negative 3. Okay, so that's my second answer. Now we're going to plot these. 22 fifths, I know my fractions, so 22 fifths is going to be 4 and 2 fifths, so I'm going to go to 4 and 2 fifths, so it's just between 4 and 5 around here. And we're going to draw a circle that's about 2 fifths of the way across between there. And this one is going to be filled in, and I'm going to put a mental note that this is going to be pointing, or it's going to be less than, so it's going to be going toward the left, so we don't want to deal with that one. So we don't want to write that down yet until we know which way it's going. And then we have negative 3. Again, this is filled in, and it's going to be greater than negative 3, so it's going to be in between. It's going to be in between again. Okay. Sometimes it could be pointing the opposite way. So, but in this case, it's in between. And what this is saying, you could pick any of these numbers that are on these two circles are in between, and it would make this equation true. Okay. That's it. That's how we do inequalities, or absolute value inequalities. All right, any questions on numbers 1 and 2? Okay, so let's have you take a moment to talk about it. 1 solid 2 is about number 1, 2 solid 1 is about number 2. Okay, so the last thing I forgot to do in number 2 is when you rewrite it, writing your final answer, you take the smallest number, which is negative 3, and then we have b that's in the middle, and then the biggest number is 22 fifths. We know b is less than or equal to negative, or 22 fifths, but it's also greater than or equal to negative 3. So that's your answer right here. Okay? So pick a problem to write. You can write both if you want, or just one. Okay, so number 3 now. Everyone's working on number 3. The answer you should have had was going to be n is going to be less than or equal to negative 1, or n is greater than or equal to negative 3. And you should have had a point at negative 3 and negative 1. Fill in your circles here. Okay, next one, number 4. Go. Now be careful with number 4 and how you write your final answer, because number 4, you never know if they are overlapping or not. Go. Okay, so on number 4, we need to isolate this. We need to isolate the absolute value sense. We have to subtract 5 first, of course. When we do that, we get the absolute value of x minus 8 is greater than or equal to 1. So we got x minus 8 is greater than or equal to 1, and then x minus 8 is less than or equal to negative 1. If we add 8 to both sides, so we got x is greater than or equal to 9. Okay, that's one of them. And then the next one is x is less than or equal to 7. Oop, going too fast here. Adding 8. So x is less than or equal to positive 7. Okay, so we got two answers here. So we go to our graph now. X is greater than 9. We're going to fill it in, right? And we said it's greater than, so it's going to be pointing right. Right? Pointing right, so we're going to draw an arrow to the right. The other one is 7. Draw a circle. Pointing left. And that's it. So, are these two overlapping at all? No. Okay, so when that's the case, remember from last week, when that's the case, you really are supposed to have x is greater than 9, or x is less than or equal to 7, right? This is really the correct way to write your answer. So you need to have that or there. If you made a mistake, please write it correctly. Okay, and it's very important that you notice that they're going out. Are they always going to overlap? Are they always going to overlap? No. So sometimes they go the opposite way. What this is saying is every number works except for the numbers that are in between 7 and 9. These don't work. Everything else will work. Okay? So that's number 4. Number 5. Number 5. Now watch carefully number 5. I want you to notice something. Number 5, whenever you have anything that has an inequality and has a negative sign, you see how it says negative 29? Okay. Okay, let's think about the concept of absolute value for a second. Absolute value I always explain, or I explain it as, it's the distance you are from 0. Or let's pretend this is your home on a number line. Okay, if I go to positive 3 blocks from home, what's the absolute value I am from home?
3 blocks.
3, right? Okay, well what if I go to negative 4 on my home? Okay, how far am I away from home? 4 blocks, right? I'm still not negative 4, right? Even though I walk backwards, I'm not negative 4 blocks, right? Just like you can't drive your car backwards, it's not going to be negative. So, absolute value is always what? Absolute value is always what? Positive, right? Absolute value is always what? What? Last time absolute value is always what? Positive. So, look over here. Is the absolute value always positive, right? So the absolute value of this has to be what? Positive. So is a positive number greater than a negative 29? Is that true?
Yes.
So any number you put in here is going to be absolute value. It's going to be the absolute value, and it'll always be positive. So when that's the case, look carefully. When this is the case, you know that the absolute value of the number is greater than this. This is always true. No matter what you put in here, this will always be positive because it's covered by absolute value signs. So when this is the case, you would put all real numbers. All real numbers will make this statement true. You could put any number for n, it'll make it true. Okay? Let's look at number 6 now. So on number 5, that's your answers, all real numbers. Number 6, absolute value of something. What does this number have to be? Positive. Is positive ever less than a negative 6?
Nope.
Is it ever? No, it's never. So since that's the case, there's not a number you could put in here that'll make this true. So then the answer is no solution. Okay?
So that's all we do?
That's it, right? Do you do this on all the problems, though? When do you know to do it? When there's a negative sign here, okay? So you kind of have to think about the concept of absolute value. Look at the sign. If it's less than a negative, then it's no solution. If it's greater than a negative, then it's all real numbers.
Wait, so when do we do that?
Whenever you see a negative sign, look at the inequality. If it's greater than a negative, then you know it's all real numbers. If it's less than a negative, then it's no solution. Does that make sense? So I want you to turn to your neighbor, explain the concept, because this is an easy problem as long as you know the concept, okay? Ready, set, go.
So the negative numbers